Good morning. Welcome to St. Martin Engineering College. I am Satish Kumar from the Department of CSC and ML. Today I am taking the topic about the introduction to data structure. First of all, what is data structure? So data structure, it is the representation of logical representation of two individual elements. So here the data structure, it is affects the design the both structure and the functional aspect of your program. So program is nothing but algorithm plus data structure. What is algorithm? Algorithm is nothing but step-by-step procedure of a sequential order in the of a given problem. So by doing this both algorithm and data structure, we can get the program. So instructions of a program can be we can do a software. From this we can know that all the step-by-step proceeding the solve the particular functions. So from here we are in the data structure, it is classified in two types that are the primitive data type and the next one data structure and the non-primitive data structure. In the primitive data structure, it having the integer, character, float, pointers, double. This way it will be defaultly it having the pointer, the primitive data structure. But in the non-primitive data structure, there are the continuous data structure and the conditional continuous and non-continuous data structure. So in continuous, it having the arrays. Arrays having the single dimensional, two dimensional and the multi-dimensional, and also having the list. In the same it having the list having the single linked, double linked, circular linked, and other stack and queues. From the this is the continuous. From the non-continuous, it having the trees and graphs. We can study with the one topic here. So first of all, primitive data structure. What is primitive data structure? They are the basic structure and directly to operated upon by the machine instructions. And next, data structure that are the directly operated upon the machine level instructions. From the and the known as the, which are known as the primitive data structure. So it having the integer, float, point number and the characters, constants, string constants, pointers are all the belongs to the this primitive data structure. By using this data structure, it means these data types. From here the non-primitives are classified from here. So next one, in the primitive data structure, it having the most commonly used operations on data are the data structures are broadly categorized into following type, which can we can the create, selection, next updating and destroy, or the we can delete it. So by using this primitive, we can do these type of operations. Next one about the non-primitive. They are the more sophisticated data structure. The data structure that are derived from the primitive data structure are called the, which means non-primitive data structure. Which means primitive from the primitive data structure only. These non-primitive are derived from that. So this type of which are called as non-primitive. From the non-primitive data structure, emphasized on the structuring of a group homogeneous, which is having the same type. It means homogeneous. So these type of data items are known as the non-primitive data structure. So next one is about the in this non-primitive data structure, it having the linear data structure. So in this linear data structure, have the kind of data structure that has a homogeneous elements. Homogeneous elements is nothing but same elements. It means the same elements. The data structure in which elements are sequenced from a linear series. So it having the linear series with a sequential order. So this is called the linear data structure are very easy to implement, and since the memory of the computer also organized in the linear fashion. So some of the commonly used linears are the stack, queue and linked list. We can study about the stack, queue and linked list. For up to that we can study about the non-linear also here. So non-linear is nothing but data structure which has data structure, data items are connected in the several other data items. It can be connected to the several other items. From here, non-linear data structure may exhibit the either hierarchical relationship or the parent-child relationship. So it having the one parent node and a parent having the child. Though and also if the child having the two childs, we will call the child as it is a child node, and also called as which is also called as the parent node. Parent node with also called as that as an internal node. So that way this will be derived from the in the trees, and the data elements are not arranged in the sequential structure. The different non-linear data structures are trees and graphs here. So here is this is of the non-primitive, and it having the mostly commonly used operations in the non-primitive data structure: traverse, insertion, selection, searching, sorting, merging, and also deleting. These operations, by using this operation, we can element can be add or we can remove, or we can take or we can search that element, we can sort them. It means from increasing order of the elements, or we can be merge them. So we can by using merge sorts, that way merging, and also we can delete totally from that list. So that way the non-primitive data operations are used here. So difference between the primitive data and the non-primitive data. So here the primitive data structure is generally for the basic structure, usually built in the difference between them is a primitive data structure is generally about the basic structure that is usually built into the language such as the integer float. But in the non-primitive data structure is built the primitive data structure in the linked list, linked together with the meaning ways such as or the linked list or the binary search tree or the AVL trees or the graphs, etc. These in the used in the non-primitive data. These are the difference of the primitive and non-primitive. From the description various of data structure, arrays. What is meant by array? Array is nothing but define of a set of finite homogeneous elements or the same data items. It means it having the same elements, same like a integer. Integer means 1, 2, 3, 4, and the float. Float also same items. It means having the decimal form. Float having the 2.1, 2.6, 3.8. These are decimals. So these type of categories, same categories, have taken the homogeneous elements. Is known as the taking of the homogeneous elements, or the group of elements, homogeneous elements, is known as the array. So a set of finite number of homogeneous elements or the same data items is known as the array. And here it means an array can contain one type of data only. Okay, here we saying what containing one type of data only. It means integer. It means having the only numbers without it having 1, 2, 3, 4, 5, 6, that way. It having that type, and either integer or float point, number, or all character. So this having the same type only. So this is about the array. And next one, in this array, the declaration of the array is int arr. Arr is nothing but array of the how much the list we will predefined already. We will giving the these many won't be. It means we are saying the static. We are saying the predefined only. We are defining before only. When our operation is going on, we are predefining. So the list may be must be in 10. So that way here the array declaration is declared here, where the int specifies the data type of elements. Here the int is the data type of the elements, and array stores in here. So ARR is the name of the array. I said no before, ARR is the name of an array, and the number specified inside the square brackets is the number of elements of an array can store. This is the number of array. So array which having the number of in the array, these many number of array can be stored here. This is also called as size or the length of array. This is called the size of array. So this way the array is declared. And next one is about the representation a linear array in the memory. So how it will represent the elements of linear array is stored in the consecutive memory locations. Okay, it is shown below. This is the linear array which is having the index 1, 2, 3, 4, 5, and the linear array which is the array with 10, 100, 20, 50, 100. The size how much is the here is the 5. So which having the address. In this base address it having with 1000, 1002. This way the base address will be for the each array element which is there. For this will be stored at this point at 1000, 1002. So this is about this linear array. And next one is about the stack. Stack is nothing but it is a linear data structure which follow a particular order which the operations are performed. Here the operations are performed. It is in stack. It is in the insertion element into stack is called push. Here when we are inserting in the an element, it is in the in a like a container. So in a container it will be we can add that in the insertion element is known as the push, and the deletion of the element of stack is known as the pop. So the order may be LIFO. It means whenever we whenever we are adding an element into the container, so first it having only one side. So it means from that side only it must be come outside. That side only it will be added. So for that one it will be then this is the container which having this is the container part. First we add 1, next 2, next 3, next 4, next 5. Example, we have a books. If you are in a class, the teacher is asked to give the books for the correction. So at that time, all the students will keep who give the first the book. The book will be the at last, and who given the last, who kept on the books, it will come the up. It means teacher will be correction from where? From the first part. It means last, the last in first out. So correction will started from the last. So this is about the stack. So it will be push and pop methods are here used. Only for method. So presentation of stack in memory is nothing but the stack can be implemented in two ways. We are using array, which is static memory, static implementation, and another one is pointer, which is a dynamic implementation. Already we studied about what is meant by static, what is meant by a dynamic. So here will be the with the stack. Here see the array implementation. So here the item will be in this way, in the one in one container type here. So top. So here will be the top top at a 0 not at a top -1, top equal to -1. It will start from top equal to -1 due to here whenever it using the top equal to 0, it means the element is already at the 0. It's the string here, the from 0 it will start 0 1 2 3 4 5, this string will start. No, so for that 0 it won't be say top equal to 0, top equal to -1 means there is no any elements in that container. If an element is there means it will start from the top equal to 0. It means top will be incremented, top plus plus. So this way the push elements will be whenever pushing, it means whenever the element is adding to the container, it will be each one will be top plus plus. That way it will be increased here. Next one, in the linked list representation, it having same this only. We can be using the this container in the this is in portrait. So in this portrait only, just we taken the item 1 and next one is item 2, item 3 and so on. This way the stack head, it having the head and rear part. This is the head part and last having the rear part. So this way it having the top. So top is item 1, item 2. See here, same this is represented in the same in the linked representation. So this way the representation of stack will be stack in the memory is taken. And next one in the operations. First of all, stack is it creates the new stack that is empty in the stack. It means stack is nothing but in a container. So in a container there is the if the empty, by using the stack method we can use this method, the stack is formed there. So that is empty. It is needs to no parameter and returns the empty stack. Next one, push. Push means it adds a new item into the top of the stack. So the container which is having the stack, at when we using this push item then the when we use this push method, it will be add one item in the container. If you want this way, we will add the every element in the stack container. And next one is the pop. Pop is nothing but we can remove an element from the stack. So the container which having the push is which pushes the item, pushing the item into the container, and the pop is the removing an item. We can remove from that. Next one, peek. It returns the top of the item from the stack out, does not have the remove it. Just peek is nothing but where the stack is where the stack, it means the top where it was on the container. This way the peek is used. Is empty, it will test the stack is whether is empty or not. By using this we can know the is empty method, we can know the container is the empty or full, empty or not. Then size, it returns the number of items on the stack. By using this size method we can know the how many items are entered in the stack. These are the operation on the data. And the stack conditions are depending on the implementation, may be necessary to check the stack is full. So full, the attempt of add is a whenever the flow whenever the container having the full, then it is called as an overflow error. So we cannot enter in the in this container. This is known as overflow error. If there is no elements are there, then it is called the underflow error in the stack. So these are the important of the these attempts of the removing, and this is a push. So whenever being here, the full of the stack is known as overflow error. If no elements are in the stack is known as underflow error. Next one, push operations. How it will push? The process of adding element into the item stack is represented by an operation called as push operations. This way, it having the empty stack first, and again from here we are entering to the here pushing the one element to the top. So top is where it will come to down. This way the adding one element to in this container as a push A. Next one, push B on this one. Next one, push A. So here will be the top plus incrementing, and here incrementing. So this way top will be increased. So this way we can the push operation is takes place here. Next one about the pop. So here is the full of the full node or the container having some elements. These elements are which the process of deleting one element or the item from the stack is represented by an operation is called as pop operation. Pop operation. When elements are removed continuously from the stack, it shrinks the same end. That is the top. It means in a container which having the each element. See, I am removing the C. So from here, elements is removing means top is top minus minus is going on. It means top B. It is minus popping. So everyone is whenever pop up, the every element will be come outside. So this way the remove from that container. So this way the A, B, C which are there, a single we will deleting or the removing from the container. This way the empty the stack. So next is about the applications, the main applications of the stack. So the main is it is used to reverse a word. So we can reverse the words when the now we kept in the CBA. So we want in the we can reverse that one ABC. Whenever coming outside, we will take in the ABC. That way we can the word of the push we can be letters are letter by letter and then pop letter from the stack. So this way the reverse we can reverse them. And also we can do the undo mechanism in the Word document or anything. We will do the undo. So this type of part is done in the by using this stack mechanism in the by using undo mechanism. And next one is the back tracing. This is the process when you need to access the most recent data elements of series of elements. Once you reach the dead end, you must backtrace. So we can whenever the bracelets, it means brackets. The brackets will be we can see. So in a program we have the brackets. So using first will open and next one close. Is it correct in the position or not? Did we closed for that open brace? So that will be traced by using this stacks. Next one language processing is a compiler syntax checking the matching the braces implementation by using stack. So this is the implementation of the stack. I said no. In the program, the braces are exactly opened or not. At this place, this will be used in the processing time. And next one is the conversion of decimal number of binary. Next one to solve the Hanoi methods. Next one conversion of infinite expression and the postfix and prefix. And also quicksort, runtime management. These all are the applications of this stack. Next one is about the queue. Queue is nothing but it is a linear data structure. It having the ordered collection of the items, same as inserted at a one end, but it having the queue. Queue is nothing but it having a one end insertion and another end is for the deletion or the removing. So it having the two ends, but in stack having only one end, that end only it from that only insert, that only from that end only it will be removed. But in queue it will be two ends. One end is for insertion and another end is for delete for the removing. It means from front end it will be removing or the deletion will take place, and from the rear end it will be insertion will be takes place. So here see once a queue is an ordered collection of the items where an item is inserted at one end called as the rear, and then existing from the remove at the other end is called the front end, which I said that only. So queue is also called as a FIFO. Yes, sir. When the for example in a queue we are in the queue like taking a ticket. So if you are taking a ticket, we will use the in a queue method, queue form. So in the queue form, who came first, he only go outside. It means first in, first out. Same that mechanism is used in the queue. So in this queue, only two operations are going, NQs and the DQ. It means NQ means the inserting the insert an item into the back of the queue. So whenever insert for the inserting method, inserting an element to the queue, this method is used for the NQ. And DQ is nothing but removing the front of the item, the people standing in the railway reservation row in an example of the queue. Same as the example of the railway station, we are taking a reservation form or the ticket from here. So this the queue is in the queue. How will be? So front who is there, he will be come outside by taking the ticket from inserting from the rear end, from front end it will be deleted. This is about the queue. And the queue having the ways of, there are two ways of implementation. One is a array, using array which is static implementation. Another way is a pointer which is a dynamic implementation. From here the pointer, so it having the front and rear as -1 due to in front. So if there is 0, if we set the front equals 0, rear equals 0, already the 0 element 0 is here. So it means already one element is already here. If we set front equal to -1 and rear equal to -1, it means no elements are there in the queue. By using this we can represent that if we getting the element, then it will be front plus plus. It means from front -1 to it moves to the by incrementing to the front of this 0. If a front rear this front rear, this will be incremented incrementally it will move by this way. So every element, see, front equals 0, rear equal to 4. Front is a 0 at 5 and rear is a 4 at where here 9. So 2 front is 2 is where 12, rear at 4 is 9. This is a representation of Q in the memory takes place. Next one, representation of Q in the memory. So here the front and rear same, which is the 12, 8. These are linked list. So each and every element will be linked to the elements in the Q. So this way the representation of Q memory will be in the linked list of every element. It means the element is the data, and this data is linked with the data of the next node. These nodes address will be linked here. So this node with linked at here. So this way the storage of the here front and rear part, the representation of Q memory is takes place in this mechanism. So representation in this method. So types of queue, they are the simple queue, circular queue, priority queue, and the D queue. So these are the 4 types of queues here. So each queue we can say that we can study about this one. What is meant by simple queue? In a simple queue, insertion occurs at the rear end of the list and the deletion occurs at the front end. See here, this is our queue, which is a string which having the insertion is this is the rear part, this is the front part. So in rear part, insertion is takes place from here. So from here, here this way, and deletion will be takes place from the front part. This way the queue structure is queue form representation is takes place. So next one, circular queue. In circular queue is a queue which is all the nodes are treated as the circular, such as that last node follows the first node. See here the last node. Here the 1. Here is the 0, 1, 2, 3, 4, 5, 6, 7. The last node, where is the 7? So 0 is following the 7. 7 is following to the 0. So this way the circular node is follows the last node which follows the first node. This is the circular queue. Next one is about the operation of queue. So in this operation of queue is it creates a new queue that is empty. So in case there is no any queue, so we have to keep the element. At that time queue method is used. This is to create a new queue. It will be by using this method the new queue will come. So by using enqueue is nothing but and to add a new item of the rear of the queue. You said, I already said no. So whenever we using a queue for insertion here, so inserting the element from the rear end, same that only here takes place. See, from the rear end only we will add an item. DQ is nothing but we can remove from the front end from the queue. Next one, empty. It tests whether the queue is empty. So empty, if the whenever we inserting element, if the queue is the full or the empty. By using this empty method, we can know the queue is either empty or empty. We can check it. Size, it returns of the number of items in the queue. So by using the size method, we can say the size of the queue. We can know here by using this method. We can know the operation of the, by using this operation of queue, we can know how the queue is implemented there. So next one about the list. Next about the list, which is the list. A list is nothing but linked list can be defined as a collection of variable number of data items called nodes. The lists are the most commonly used in a non-primitive data structure. These are in the non-primitive data structure. Each node is derived from the 2 parts. The first part contains the information of the element. The second part contains about the memory address of the next node in the list, also called as the link part. So this is the start from the information. This is the information. Okay, we'll take in the one program we can do here. 1 minute. Note. Okay, about the insertion in a linked list. Insertion in linked list. How an item will be inserted in linked list. First of all, you have to know in the linked list there is the node. Node having, here will be the data, here will be the link. So data and link, it means here in this node they are the node will be here in the struct node we call as nodes. In these nodes it will be in the data, and here will be the link. Link is nothing but other nodes address, this address. Here also will be data, other nodes, here also will be the link. This is the front part, we will say front, and this is the rear part. Okay, so something here is the 20, the address of this one, address of this data link, which is the this part, and here will be the 30, which is null. We can say the address of this one maybe 1020, I think. So the address of this one is 1020. So this way the front and rear part we can we know the link, it will be links from the front and rear part. So rear of the node, struct nodes. So from here we can do the program how an element can be added into that. So first of all, the program hash include stdio.h hash include conio.h. So here I want to create an node here. So for creating struct node, so for creating I want what here, first I want a data and the other one is the link. So this means, so first of all I need data. Data is nothing but int. Which type I want here, which are in the number format, it means integer form. So int data, int data, next one in I want in the next node is with a link. It means node we can call as a node, or the struct node also we can call this struct node of star link. Okay, this is closed. I need only this parts with the struct node. It means by using this I got the node data, and the next one is the link. So by this I am defining from here only, I am calling that with the names of star front, and another one is front, and another one is star rear. Directly I called here rear. See, front one will be, this will be defined, and the rear is this way defined here. So directly we will get the individual elements here from the front and rear. From here if I want a newly element I want to create here, it means a temp file we can create. We can keep here star temp means we will get, but we can create newly here like temp equal to, it means I want a temp file I want here. So temp file I want this way with the name temp, which having the same data I want, and another one is link also I want here. For every individual element, individual node, so there will be the linking will be null here for every individual node. So it means the temp is equal to struct node. When I call here the node with new struct node, so whenever I call this one, it will directly goes to here, and this will be figure out here for us this way, temp with this all. So here will be the temp file which having the with the front what I want, front temp of front equal to 10. I am directly giving here, or we can int, we can give here int equal to int e equal 10. When I can call here e. Next one is a temp of front, next temp of link equal to null. So this way we get an 10 equal to null. This way temp will be filed here. Okay, now I want to insert here. So insert here. Okay, this way will be the one element can be create here. So by creating here we can next we can be we have to link there. So we are link means first of all we have to know the if condition. If front equal to null, then if the front equal to null, then we can say front equal to rear equal to front, sorry, rear equal to temp, rear equal to temp, and front equal to temp. No, else. If not there, if not there means anything not there means we can directly it will be insert there. If not means if we want to, if already there elements, then temp of, if there means temp of next, which means this is the next item have to be linked to the front, equal to front, and front equal to temp. So free the temp, then it will become as the front will become as, front will be here, here will come, temp will be removed. This way the in this area will be takes place. Next one about we can do in the animation part. So animation, I have the one animation video here about the total process about this one. So in this the video is nothing but about how the arrays will be do stack, queues. Okay, here is the data structure, how in the animated video how the array is removed from a list. We can say the remove list is from here, I want from here to add this one, so from this so it will be add in the array. And next one is about the how an element can be deleted. So from this deletion we can do, here is the first element is a when I am deleting here the from the linked list using, so the next part will be the head of this element. And next one how in the stack, how we can keep in the stack. So each and every it will come the top plus top, see from top to inserting to down from the first part, and next one is the next, this way the in a stack will be takes place. Next one queue, see it will going to the first it came and it going to the out, it means removing from the queue. Same as the second one, this way the FIFO will be takes place, is first in first out, this way the takes place here. So thank you for giving this.